Have today in the gift box? Let's see. Ooh, they are parts of a sports airplane. Let's start the assembly. Look, here is the base of the aircraft, the fuselage. In the front, there's an engine and a cockpit just behind it. Let's add the aircraft canopy. This is a transparent enclosure over the cockpit, which provides a weatherproof and reasonably quiet environment for the pilot. To the bottom of the fuselage, we'll attach the landing gear, so that the plane can ride on the runway. On each side, we'll attach the wings. Without them, the airplane won't fly. At the rear of the wings, there are flaps and ailerons. Now we need to assemble the tail unit, which will ensure the stability of the aircraft in the air. This is the vertical stabilizer. On the rear edge of it, there is a rudder. Now we'll install two horizontal stabilizers. On the rear edge of the horizontal stabilizers, there are elevators. Now we'll add the navigation lights to our aircraft. The red one goes on the left wing, and the green one on the right wing. This ensures that other pilots and observers from the ground can determine which direction the plane is flying. Finally, on the nose of the aircraft, we'll install a propeller or air screw. The propeller is connected to the motor shaft and will generate thrust. Hooray! We assembled our airplane. It is now ready for flight. By the way, do you know how the plane flies? Before takeoff, the aircraft accelerates along the runway. It is moving faster and faster, which means the oncoming airflow is getting stronger. If you've ever ridden fast on your bike or scooter, you're familiar with this phenomenon. The upper part of the plane wing is more convex than the lower one. Therefore, the air traveling over the top surface of the wing has a longer path than the air traveling below the wing. But the amount of the air flowing onto the wing and down from it is the same. The air traveling over the wing has to catch up with the air traveling below the wing, and that's why it has to move faster. The air under the wing becomes compressed, while the air above the wing becomes rarefied. This creates a higher air pressure under the wing and a lower air pressure over the wing. The compressed air under the wing presses on it from below, creating lift, which pushes the plane upward. The faster the plane moves, the greater the lift force is. At some point of acceleration, it becomes sufficient for the plane to take off. Well, let's get into the cockpit. The cockpit is equipped with a variety of instruments and tools. This is the control wheel, or yoke. It plays the same role as the steering wheel in the car. And here are the rudder pedals. This is a throttle control and a mixture control. Here are the main instruments the pilot uses. This is the attitude indicator, also known as an artificial horizon. It shows the aircraft's relation to the horizon, the angle of the plane's inclination up or down, left or right. The vertical speed indicator. It shows how fast the aircraft is picking up or dropping the altitude. 0 means that the plane is flying at a constant altitude. The heading indicator. This tool serves as a compass for the pilot. The altimeter. This shows the altitude above sea level. The airspeed indicator. The turn and slip indicator. This tool simultaneously shows the angle of rotation of the aircraft relative to the longitudinal axis and the transverse axis, which tells the pilot when the aircraft is flying sideways. Well, shall we fly? Off we go! Request permission to take off.
You are clear for takeoff.
Adjust the mixture control. Push the throttle control toward maximum. We're gaining speed. Now we lower the flaps. Flaps change the curvature of the wing and increase its lift coefficient. Pull the yoke control back and lift off! Look, the elevators on the tail are deflected, and therefore the plane rises and picks up height. The altimeter shows the rise in altitude. Now the aircraft has a nose-up pitch. That means it is inclined to the horizontal plane and the airplane's nose is pointing upward. With the help of rudder pedals, you can change the yaw angle. That is, slightly turn left or right, since the pedals are connected to the rudder. Now we'll execute a banking turn. To do this, tilt the control yoke to the left. The ailerons on the wings will deviate to opposite sides, which will roll our aircraft. If you hold the steering wheel in the extreme position, the aircraft will perform an aerobatic maneuver called an aileron roll. The aircraft makes a complete rotation on its longitudinal axis while following a helical path. Now we'll make a Nesterov's loop, or dead loop. This aerobatic maneuver is like a somersault in the air. It makes a closed loop in the vertical plane. And finally, the most dangerous aerobatic maneuver, the barrel roll. This will take our plane down a helical path towards the Earth in a corkscrew pattern. And now for the last few tricks before we land. Push the control yoke forward. We are descending towards the ground. Let's fly under that bridge. And between the pylons. It's time to return to the airport. Request permission to land.
You are clear for landing.
We lower the flaps. Pull the control yoke. Touchdown! Congratulations on your soft landing, pilots. Excellent flight.